Welcome to the DEB Pre-Junior Cert Graphics exam for 2023. So we're looking at question 3 here. The image on the right shows shown on the right is the image of a retro handheld Space Invader game console. So it's just a handheld console we used to play with. Part A, the image below shows a 3D model of one of the batteries used to power the games console. So we've got a 3D image of the battery. The elevation of the battery is also shown. So here's the elevation of the battery here. Draw a new battery similar to the one given with the length AB increased to AB1. So we're trying to increase the size of this battery so that the base is no longer that long, it's that long. And everything will increase at the same proportion. So what we're going to do is we're going to radiate A is going to be our radiating point. It's the important point, and we can see it's in the new battery and the old battery. A and A. So A to B has already been radiated out. I'll call this C, call this D, E, F, G, and H. So let's radiate out from A through all of those points. Okay, so we've radiated out all those points. Now, when I increase the size of this, right, my lines are going to stay parallel to the original lines. So A to B is increasing here out to B1, which is technically a parallel line to the existing AB. B to C is a vertical line, so I'm going to be parallel to B to C as far as there. And then C back to D, that's a horizontal line. So I'm going to run a parallel line back and show that down. That's B1, C1, D1. Now we want to find that top little element of the battery, and we need to remember parallel lines. So if I follow H up, H is going to be there, H1, E is going to be here, E1, okay, on that line. H to G is at that angle, so I'm going to go, here's G coming out, so I'm going to use a parallel line to HG, slide it out, parallel, and there's G1. G to F, right, that's a horizontal line, so I'm going to run horizontally across here. Actually need to extend on my F, radiate it. So here's F1, and I can join that back to E, which is actually, if I want to use sliding set squares, they'd be parallel lines as well. So that is my battery increased, right? That's my enlargement question. Part B, the image on the right shows one of the controllers in the games console. The outline drawing of the controller is shown below. The controller is rotated 50 degrees clockwise about point O. So O is going to be our center of rotation, and we're rotating until it travels 50 degrees. Draw the controller in its new position, show all constructions clearly. So I'm going to label these points, all the points of my object. So I've got A, B, C will be the center point, D, and E. Okay, so they're all the points that need rotating. Okay, I need to now get my protractor. Okay, I need to measure an angle of 50 degrees. So it's rotating, creating an angle of 50 degrees. So I'm not measuring it like that. I need to make sure it travels 50 degrees. So line up my bullseye with O, 10, 20, 30, 40, 50. Okay, so that's my center line, first of all. Okay, OC is on that center line. So I'm going to rotate about point O, so O being my center. So there's point C1. Okay. While I'm here, I'm actually just going to draw my circle C. Okay, so that's the top part rotated down. Now we need to find A, B, O, and E. Okay, so let's rotate all of those points first of all. So B and D. Try to rotate them. They should be in line with each other, which they are. So I'm going to rotate those down. Okay. E and A. These are going to be tough to rotate because they're so small an angle. A smaller radius, so we need a good, accurate track of compass here. So rotate, 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 rotate. Right, so. Okay. Now, the distance from C to A isn't going to change when it comes over here. So, A is rotated along that path, that circular path, but the distance doesn't change. So, C to A will stay the same. So, from C, I'm going to swing an arc, and that finds me my new A. That's A1. The distance from C to E also won't change, which is actually the same as there. So C onto that line rotated. So this is my E1. The distance from B to C, I've actually already found by drawing that circle, and the same with D. So I can actually start drawing everything up here. So this is my B and D, so B1, D1. Draw that. And join A across to E. And I'll just go a little bit heavier here for my outline. Okay. So that's my rotation. Part C. The graphics used in the retro game were very basic. The image on the right shows a spaceship used in the game. The outline drawing on the right shows the elevation of the spaceship, which is based on a regular pentagon. Okay, regular being all sides are the same length. Complete the drawing of the spaceship below. So they've given us the base and they're telling us that this is a pentagon shape. So we'll draw our pentagon. So pentagon has 5 sides. We're going to divide 360 degrees by 5, and I know that works out as 72 without using my calculator. So get my tractor, line it up at the end here. 72. So 0, 10, 20. Up to 70, and let's make sure we go to the correct side, so 72. Right, so that angle is 72. The same here. That's what we're measuring. Now I'll just draw a light line out here for now. And 72 on the opposite side. 10, 20, 30, 40, 50, 60, 70. Up towards the 80 side, so 72. Okay, now regular pentagon, all sides are the same, so that base is the same as the length of one side. So just show that in small up, and the same here, they're the same length. That's one side, that's the other side. Now I need to find the top, which is going to be equidistant, so same distance again. Here I have my pentagon shape, pentagon outline. Okay. Okay. Just looking at the constructions here, I'm going to draw my triangle there. It's actually an isosceles triangle. Okay, then I want to find these two lines which are parallel to the outside there and there. I don't have a position of that and that, but I do know if I join across, that will find me those 2 points. So, light line across, and now I can use my sliding set squares to draw parallel lines, sliding set squares. Great. And finally, finish off with a heavy and heavy air. And I mentioned nothing about colouring, so I don't need to colour that in or shade it. Right, and finally then, the image on the right shows the on-off switch of the console. The on-off switch. The console is switched on by moving the switch to the left to the on position. So it's off, we're moving it, sliding across to the on. So this needs to be slid across. The diagram below shows it in the off position. Yeah, off. Complete the translation from A to A1 to move the switch to the on position. So it's a translation we're doing. Translation, all points move in the same direction, the same distance. So let's call this B, C, D, E, F, G, H. Okay, so A1 is our direction, first of all. Right, so it's a horizontal projection, so that's already done there. B, let's project that. D and E projected across. F and G projected across. Okay. We want to then say that everything is traveling the same distance as A to A1. So A to A1, everything will travel that same distance. So B is traveling to here, C is traveling to here, D, E, F, G, and H. So that's my B1, C1, E1, G1, H1. Now I know the temptation is just looking at this to draw vertical, horizontal, vertical, horizontal, but we need to show how we found those distances. It won't always be presented as easy as that, it might be projected at an angle. But we can draw this quite simply, joining up our points D to C, E to F. It's kind of an easy question. We complete our other lines, B to C. Okay, so translation completed there for question 3. Okay, there's one last piece of question 3, and I'll do that in a separate video.